everyone! Today we will discuss the two famous astronomers on modern age, which is Tycho Brahe and Johannes Kepler. Also, we will emphasize the three planetary motion. On this lesson, we will have an objective. The first objective of this study is to determine the works and life of Tycho Brahe and Johannes Kepler. Also, describe the relationship of Brahe and Kepler to discover the planetary motion. And 3. Identify the three planetary motion. So first, let me emphasize who is Tycho Brahe. Tycho Ottesen Brahe, a Danish astronomer and Nobel who made accurate astronomical observations. Born on December 14, 1546 in Skagen, Denmark. He was kidnapped by his uncle and aunt and lost part of his nose in duel at the age of 19. Used prosthetic nose. So yun, si Tycho Brahe ay isang astronomer na galing siya sa bayamang pamilya. Pinanganak siya noong December 14, 1546 sa Denmark na ngayon ay Sweden na. Siya ay kinidnap ng kanyang uncle at auntie. Kasi yung uncle at auntie niya ay walang anak. Kaya siya yung parang gustong maging anak. Noong una hindi gusto ng parents ni Tycho Brahe. Pero dahil naawa nga din sila, edi parang pina-adapt nila si Tycho Brahe. Pero ano naman, kino-consider pa rin ni Tycho Brahe na biological parents niya talaga yung kanyang tunay na magulang. And then yung uncle at auntie niya, yun yung ginawa niyang poster parent habang siya tumatanda. And at the age of 19, yung kanyang ilong ay naputol. Kasi may lasing siya that time, then parang nagkaalitan sila nung kanyang isang kasama sa school. And by that, parang naghamunan ng mag-fencing, then doon naputol yung kalahati ng ilong niya. And habang tumatanda siya, ang gamit niya ng ilong ay yung prosthetic nose. Additionally, Brahe kept elk for a pet. Also, he considered one of the most important astronomers in Middle Age. He collaborated with Kepler until his death on October 24, 1601. The cause of her death is bladder infection. So yun, meron siyang alaga, naging alagang hayop, na yun ay kino-consider as kind of deer. Ang elk ay ikalwa sa pinakamalaking species sa family deer, na parang reindeer doon. Parang may pagkakahawig sila ng reindeer. Then, namatay si Brahe noong October 24, 1601, na kasama niya na doon si Kepler. Ang cause of death niya is bladder infection kasi napabayaan niya rin ang sarili niya. Dahil mayaman nga, edi maraming luho na nabibigay sa sarili niya na hindi niya na naalagaan yung sarili niya. Yun.
Here are the different works of Brahe. He created detailed mathematical tables that astronomers used for centuries. The main purpose of the Rudolphine tables was to allow the computations of the potential of the known planets of the solar system. Second is, he built his own observatory called Uraniborg. Uraniborg was a Danish astronomical observatory and alchemical laboratory. And the third is parallax. Parallax refers to the apparent change in position of an object based on observer's location. And the last is, he invented his own versions of the frame sextant. Frame sextant, which measured the distance between the stars and the wooden quadrant, a semicircle connected by two rulers that measured the altitude of heavenly bodies.
So, ang nagsama natin na pag-uusapan ay yung pag-disagree ni Brahe. So, why Brahe disagree to Copernicus model? At dahil dyan, meron akong tatlong dahilan kung bakit nga nag-disagree si Brahe. So, first is geocentrism. Geocentrism is widely believed during the time that Copernicus presented his model of planetary motion, making Brahe question the latter's discovery. Planetary motion, nasa gitna nun is sun. Tapos si Brahe nagkaroon ng disagreement about dun sa theory kasi sun nga daw yung naikot. Kaliwasin sa discovery niya. So, hindi niya pinanigan si Copernicus about dun sa discovery niya. At dahil din dun sa geocentrism, na-question yung latter's discovery niya. Pangalawa, he could not observe parallax, which convinced him that Earth is not moving. Ano nga ba yung parallax? Parallax, ito yung displacement or difference in the apparent position of that object view along two different lines of sight. At dahil na din dun sa point of view na nag-o-observe, kaya siguro nag-disagree si Brahe. Maybe Copernicus ay nakita yung, di ba, pag-parallel, pag-ganto. Dalawang line, hindi sila nag-minute. Nakita nun ni Copernicus is nag-minute. Kaya ba, ito line, tas line. Nang nagko-connect ba sila, may dumadaan sa kabilang line. Si Brahe, hindi nakita yun. Maybe nakita ni Brahe is ito yung line, hindi nagsasalubong. Wala man lang connection, walang nag-minute sa dalawang line na yon. Dahil nga din sa mayroon nga tayong magkakaibang point of view, in simple, it is to see is to believe. Pangatlo, he has his own model, the Tychonian model. From the word Tycho, si Tycho Brahe ay gumawa ng isang model na ipinangalan niya sa kanya. Tychonian model ay para siyang geocentrism, which is the Earth is the stationary and at the center of the planetary system. The Sun and the Moon revolve around the Earth and the other planet revolve around the Sun. So yun po yung tatlong dahilan kung bakit nga ba nag-disagree si Brahe kay Copernicus.
Johannes Kepler, born in 1571 in Wil, Germany, was a man of extraordinary intellect and unwavering dedication to unraveling the mysteries of the universe. He was born prematurely and physically weak. His family was poor. He had 6 siblings. 3 of these died already at an early age. Kepler's early life was marked by poverty and illness, but he displayed an exceptional talent for mathematics and astronomy. He studied at the University of Tübingen, where he was deeply influenced by the teachings of Michael Maestlin, a renowned astronomer who introduced him to the Copernican model of the solar system. Kepler's life was not without its challenges. He faced religious persecution, financial hardship, and personal tragedies, including the loss of his wife and children. Yet, he persevered in his pursuit of knowledge, driven by an insatiable curiosity and a deep desire to understand the universe's intricate workings. He was a prolific writer, publishing numerous books on astronomy, mathematics, and philosophy, sharing his insights and discoveries with the world. Johannes Kepler's life was a testament to the human spirit's ability to overcome adversity and make groundbreaking contributions to science. His legacy, marked by his revolutionary laws of planetary motion, continues to shape our understanding of the universe and inspire generations of scientists and thinkers.
Ngayon po, tatalakayin natin ang naging connect ni Brahe at Kepler sa isa't isa. Kepler was Brahe's assistant during his lifetime. Brahe did not want Kepler to see all the data for fear that Kepler might to get their first theory of the planetary motion. But on his deathbed, he granted put over the data to Kepler with his blessing to continue his work. Kepler built upon Brahe works, and if anything solidified its importance, Brahe was the most skilled visual observer at that time and complied usually accurate position of the stars and planet. Brahe, however, was not skilled theoretically, and it was Kepler who used the Brahe observation to make fundamental breakthrough in celestial mechanics. Kepler minded Brahe observation to find the diamonds contained in them.
Other works of Kepler. Number 1. He discovered how picture form in the eye. His work on optics was equally groundbreaking. He wrote Astronomia Pars Optica, which explores the properties of light applying the ideas of reflection and refraction to explain astronomical phenomena, such as the size of astronomical bodies and the nature of eclipses. It also investigates the working of the light with regard to pinhole camera and the human eye, without performing new experiments and solely by application of the laws of light refraction. Number 2. The Keplerian telescope. Keplerian telescope was invented in 1611 years ago, just 3 years after the discovery of the first telescope in the Netherlands, by replacing the concave eyepiece used by Galileo with a convex lens. Kepler was able to make considerable improvements to the design. Although this inverted the image produced, it enabled a much wider and larger field of view. Number 3. Investigate the orbit of Mars. Kepler managed to discover the actual shape of the orbit of the planet Mars in its circulation around the Sun, as well as the rule governing its motion in the orbit. Kepler discovered that Mars' orbit was likely to be an ellipse, with the Sun and one of the ellipse's focal points. This, in return, led to Kepler's discovery that all planets orbit the Sun in elliptical orbits, with the Sun at one of the two focal points.
Kepler formulated 3 laws, and his first law is law of ellipses. It says here that planets move in elliptical orbit with the Sun as a focus. All planets orbit the Sun in a path that resembles an ellipse, with Sun located at one of the foci of the planet. Basically, Kepler saying in his first law that the planet don't move, or each planet move to the Sun in an elliptical way and not in a straight way. The second law is law of equal areas. It says here that a planet covers the same area of space in the same amount of time, no matter where its orbit. Basically, Kepler is saying in his second law that the planet closer to the Sun, called perihelion, move faster or orbit faster to the Sun, rather than the planets or object far from the Sun, called the aphelion. Kepler's third law, named law of harmony, says that a planet's orbital period is proportional to the size of it. The example of this is that's why Mercury, the inner planet, takes only 88 days to orbit the Sun. The Earth takes 365 days, while the Saturn requires 10,759 days to do the same. Though Kepler doesn't know the gravitation when he formulated this or his 3 laws, it is helpful to Newton because Newton formulated his theory, the theory of universal gravity.